is the complement of the ants. So these are not. It's so much. But you maybe perhaps you can get the intuition of what the way we are using the Cs. That is a kind of condition. This maybe we need to explain this better.
And you can say that you have defined a new method for making pattern recognition based on these formulas, but not trying to say that it's a fuzzy finite machine and trying to adapt rules to this equation. It's completely unnatural.
No. I think that
we
are not explaining more than the needed for explaining pattern recognition method.
I think if you say that you have some fuzzy rules, you expect some activation of the rules, some T-norms, T-conorms, something that usually people working with fuzzy is used to work with it.
The same thing in this approach, the only thing that we need.
But what you are telling us is you are trying to explain the behavior of the system with some rules that seems to be fuzzy rules, but if you go back or you go inside the system, there is nothing fuzzy rules there. You have other different formulas that your own interpretation.
I think that is the second explanation of we are working now. It is useful for him, but it is not needed for in general for explaining how the system works, because it's so simple as to say the designer must look for rules for remaining one state and rules for change the state, only that. And then the rules are the rules that has been written up in the first slides. They are the rules. Maybe one topic is how these activations are translated from one or the other, or maybe we must explain that there is a normalization step, because without that is more difficult of understanding, but with that is enough. We are now working in this other method for
the main thing is usually when you have a set of rules, they have to have the same formalization for all the rules, the same kind of operators. For example, you have 4 rules for the state, another 4 rules for the transition of the state. They are completely different, and I suppose they are not activated at the same time. If they are activated at the same time, there is something else there also.
No,
because you can compare the first 4 rules one side and the other 4 rules the another side. They are similar, they have the same format, but if you activate all of them and you mix all of them, and each rule has different format, different or, different and, one with minimum, other with maximum, nobody is able to interpret this rule. Not with fuzzy, not with
from that point of view, but in this case it's very simple. We have rules for remaining and rules for change.
But they don't match to the formulas that we have. The problem is you have some formulas that you say are working very well. Just use the formulas. Doesn't try to say that they were fuzzy rules, because the formulas are the formulas.
Usually when you
have this formula, you say, okay, we have to stay in the state, we have this formula, and it's blah, 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 and it's the formula that he used. To change the state is this formula, but they don't have anything to do with the fuzzy rule you put at the beginning. There's no relation.
When you say that a fuzzy system is interpreted, it's because there is a format that you know and the reader knows perfectly, and you say, I'm using this format for the rule with this operator for conjunction, for implication, for aggregation, for the falsification, and the reader understands it perfectly because he usually works with this kind of system. You can't want something else. No, the problem there is a free interpretation from the reader.
I think we have a work for next work to explain better this idea. But we are more or less confident because we have obtained good practical results. The more important is that at the end we must be able to explain better what we are doing. I agree with both of you. In different points, because Sergio insists that we must explain if we are using or not fuzzy rules, for instance. Maybe that is
no, because in the implementation you are not using fuzzy rules. You are just using this.
Okay, but we can and we have to.
That you must be careful because maybe here you have made an interpretation, an experiment with 11 people with in total 200 samples, and what happens if you have 200 people with different patterns and everything start to mix, and then you can guarantee that the result are really good, but you are.
We have a limited capacity.
But you need to have at least a mathematical basis strong enough in order to try to generalize the result. You can say, I have made an experiment with 10 people and the results are really good. I have 97% of but there are something.
And also you need to consider with other method because we already said that you need that neural networks support vector machines or other classification. 3%, if you do compare with anything, it's not very meaningful. Maybe you do with neural networks 100%.
In pattern recognition, you use parameters.
No, but you need to compare.
But you have to apply another method and the same data that you have.
They use a Gaussian distribution, and the number of samples is very small. Why not use a Poisson distribution? This close to the number of points to a telephonic sample. I was surprised by the use of a Gaussian distribution.
It's equivalent to use a trapezoid, particularly for us.
Well, if you use a trapezium, if you correct the rules and use a Gaussian, at the end, maybe the result will be a miracle.
No, the miracle appears when we use this system to distinguish very sharply every one of 11 persons using data about the way they are working. That is the starting point. And of course, we are working in a generalized system. We are working in. We have not that. We are working because we are in a progress of researching. Probably, or always has been done, we lack is the formalization of the process. We need to take more care or to progress to improve the capacity of formalization. But we have the results.
Mainly because Takagi-Sugeno is a very clear system of inference that should be used exactly as they is used, because there cannot be changes in Takagi-Sugeno. Of course, you can change Takagi-Sugeno, because we are doing the inference by another system. Why not if the system works? I don't know. But for me, let me say, the use of formal idea on Takagi-Sugeno is a little bit surprising, because in fact, as I think I saw here, you don't apply exactly the rules you have, but you change them. I did not understand why you place the maximum. Where is the maximum in Takagi-Sugeno? There is no maximum. There is no maximum.
You could have a maximum in the antecedent, but you need to then follow the maximum and give that maximum. You cannot change in the middle.
Of course, but there is a question why.
Yeah.
Why?
And I think they are not using the maximum.
Not against. I always say why. Because it is not in Takagi-Sugeno. I don't know.
Yeah. To me, there is two questions. One is because I know how you made this equal error rate and how you have this one leaf out and the rest in. To me, I think I already told you that you need to have two separate sets of data, one for testing and one for training. Because otherwise it's very easy that you tune the parameters very well to fit the data. Because here there are so many parameters already probably fit by you by hand. Playing with this one, maybe we have to move a little bit here. The time to stay is this one, the time to leave is this one. So you have to be very careful because you can even, how will I say, lie yourself. Because you start tuning, playing with the parameters until you can get very good error rate, but you don't know if when you have a new set of data, completely new, if it will fit or not. Because you don't have separate the test data and the training data.
Parameters. This, and I can tune these parameters. These parameters.
No, I mean to get these parameters, you have done all these linguistic labels, all these analysis, all the average, so you have for change probably, choose many parameters to arrive to these three values. You know what I mean?
They are very simple. They have very simple definition.
Yeah, I know the definition is simple, but the thing is,
very simple.
you have to
adapt it for anything.
leave one out when you only have